We're going to use integration by parts to evaluate the integral of cosine of the natural log of x. First, recall that cosine of ln of x, this is a composition of two functions, cosine with natural log. It does not equal to the product of cosine of x with natural log of x. We'll be integrating the function on the left, not the function on the right. Here's the integration by parts formula, how it's derived. It comes from the product rule of differentiation. When we differentiate the product of two functions u and v, it's equal to u times the derivative of v, which I'll call dv, plus v times the derivative of u, which is du. If I now integrate both sides, the integral of the derivative of the product is equal to the integral of u dv plus the integral of v du. By fundamental theorem of calculus, the integral of the derivative is just a function that is u times v, and that's equal to the integral of u dv plus the integral of v du. Let's solve this for the integral of u dv. When we have the famous integration by parts formula, the integral of u dv is u times v minus the integral of v du. The idea is to let a difficult integral be integral of u dv. We call part of it u, the other part dv. From there we'll find du and v expressed difficult integral in terms of what's on the right, and hope that the integral on the right hand side is somehow easier, or at least leads to the solution of the original integral on the left. So let's get back to integrating cosine of ln of x. I'm going to write it as integral of cosine ln of x times 1 dx. We have to decide what is u and what is dv. There's really one choice. U has to be cosine of ln of x, because if it's not, then dv has to be cosine of ln x. To go from dv to v, we have to integrate, which is what we're trying to do in the first place, so dv has to be 1. And from here, du is equal to minus sine of ln of x times 1 over x dx, and v is x. We could take v to be x plus 2 or x minus 10, but adding or subtracting a constant will make it more difficult, so we'll just use x. Now returning to the integral of cosine ln of x by parts formula, this is u times v, which is x cosine of ln of x minus the integral of v du. Now here's du and here's v. First note, there is a minus in front of the sign. Minus a minus will be plus, and then 1 over x and du with x and v cancel. So our integral on the right is the integral of sine of natural log of x. You always ask a question, is the integral on the right easier than the integral on the left? In this case, the answer is clearly no, it isn't. It's the same type of integral. So you may kind of give up and say, that's not what, it's not going to lead us to a solution. I'm doing something wrong. The technique is wrong. But sometimes integration by parts needs to be applied again to the integral on the right, and that is what we have to do. So this is, we're on our way to the solution, but we just have to apply integration by parts again to the integral on the right. So I'll write it as the integral of sine ln of x times 1 dx. This time again there will be our integral of u dv. Same principle as before, u must be the sine of ln of x and dv must be 1. So du is cosine ln of x times 1 over x dx, and v again is x. So let's write up this. The integral of sine of ln of x dx is equal to u times v, x times the sine of ln of x minus the integral of v du. This time there is no minus in front of the cosine. 1 over x and x cancel, so this is cosine ln of x dx. And let's put everything together. We started wanting to find the integral of cosine ln of x. We applied integration by parts once and got x cosine ln x plus the integral of sine of ln of x. We then applied integration by parts to the integral on the right and got the following. Here we have our x cosine ln x, and the integral of sine ln x is x sine ln of x minus the integral of cosine of ln of x. Let's eliminate the middle part here and just write the original integral of cosine ln x is equal to x cosine ln x plus x times the sine of ln x minus the integral of cosine of ln of x. When you look at this first, you may say, we did integration by parts twice, applied it twice, ended up with the same integral on the right as we did on the left. It's like we're going in circles and not got the solution. But the solution is kind of staring right at us. Notice that the integral on the left is integral of cosine ln of x dx. On the right we have the very same integral with a minus sign. So by using a little bit of algebra, we're going to move this integral from right to left. The minus will be plus, so it's just like adding two identical integrals. The left looks like twice integral of cosine of ln of x, and the right hand side doesn't have any more integrals. It's x cosine ln x plus x times the sine of ln x. Now divide by 2 and we have our solution. So it's kind of an indirect way of solving it, but nevertheless it's a valid solution. The integral of cosine of ln of x is equal to 1/2 x cosine of ln of x plus 1/2 x times the sine of ln of x. And now we can add a constant of integration c. And so this is how applying integration by parts twice leads to the solution of this integral. For